Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about Boolean forms. In previous lecture, we have studied about Boolean function and we know that Boolean function can be represented with Boolean expression and Boolean expression can be represented in different Boolean forms. So we have two different Boolean forms. One form that is known as the sum of product. In short, we know it is a SOP, and another Boolean form that is known as a product of sum. In short, we call it POS. So Boolean expression has two Boolean forms. One is sum of product and another is product of sum. Before we start studying about SOP or POS, let us study about product term. So in product term, we have Boolean expression, and Boolean expression we know that normally it is composed of different literals. We have either complemented or uncomplemented literals. As well, we have logical operators. In case of product term, we know that we have logical operator and that is AND operator, and we use notation dot for indicate logical AND operator. If we take the example of product term, then it can be represented as A bar dot B dot C dot D bar. So in product term, all the letters are connected with dot, that is AND operation. It can be a complemented or it can be a uncomplemented. Same way, let us study about the sum term. Again, in case of Boolean expression, if it is represented in sum term, then again we have letters either complemented or uncomplemented, and logical operator we use to indicate sum term, it is OR operation, and notation we use for OR operation, that is plus sign. If we take the example of sum term, then it can be represented as A plus B bar plus C plus D bar. All the letters are connected with plus sign. It can be a complemented, it can be a uncomplemented. And we know that number of letters that depend on input variable. It is always 2 times to the input variables. If input variables are 4, A, B, C and D, then we know that we have total number of letters 8, 2 times. So it can be A or A bar, B or B bar, C or C bar, as well D or D bar. Now let us see sum of product. We have one Boolean function. It is represented in Boolean expression, and Boolean expression is in sum of product form. So we have this product A dot B dot C bar, A bar dot B dot C, and this all are known as a product term. So all product terms are connected with AND logic operator. So we have 3 product terms and we have added all the product terms together. So here we have plus sign, and that is for the logical OR operation, and it is known as a sum. So this type of representation is known as the sum of product, SOP. We have sum of different products. We have total 3 products and we have added all the 3 products. So sum, that is OR operation, and product, that is AND operation. Now we have standard SOP form, and then it is known as a canonical SOP form. Suppose we represent similar Boolean function, then we know that we have product terms and we have sum terms. Now all the SOP cannot be canonical form. In canonical form, what we need is we require literals of all the variables in all product term. For example, if we see in first product term, it is only a dot b. So literal of c variable is missing, and that is why it cannot be a canonical sum of product. If we write the same Boolean expression, again we have first term, that is a bar, b bar, c plus a b c bar plus a bar b c. Now we can see that in all the product terms we have all the literals of different variables. We have a, b, c, three different variables, and we have literals of a, b, c in all the product term, and then it is known as a canonical standard SOP form. Now let us study product of sum, and in short we call it POS. So we have again written one Boolean function. It is represented in Boolean expression. Now we have sum terms, a bar plus c, a plus b bar plus c, a plus b plus c bar, and these all are known as the sum terms. In case of sum terms, all the literals are connected with OR operator. All the sum terms are multiplied together. So we have dot notation, and then it is known as a product. In case of product term, we know that we have AND operator. So product of sum, we have multiplied all the sum terms together, and then this form of Boolean expression is known as a product of sum. Now again, canonical or standard product of sum. So we write the same Boolean function, and we know that we have different sum terms as well we have product. So now again, to have a canonical form, what we need is in all the sum terms we require literals of all the variables. Now in the first term if we see, then literal of b is missing, so it cannot be a canonical POS form. Suppose we write function as a bar plus b bar plus c dot a plus b bar plus c dot a plus b plus c bar, then it is sum terms, and as well we have product. Now in this Boolean expression we can see that we have three different sum terms, and in all the sum terms we have literals of all the variables. So here we have ABC, ABC and ABC. So if literals of all the variables are available in all the sum terms, then it is known as a canonical POS. Thank you very much for watching my video. Keep watching. Thank you very much.